So, hello everyone. We'll be starting in a couple of minutes. Meanwhile, can you give me a yes in the chat box if my audio is clear? Can I get a yes in the chat box if my audio is clear? All right, let's begin then. So, hello everyone. Thank you for joining in on a Sunday night. And I'm Chetan Shiraguppi, a core committee member at ISTE-VIT, and I'll be taking today's webinar on blockchains and smart contracts. So, without any further ado, let's dive straight in. So, what all are we going to learn today? We'll start off with the basics of what is a blockchain and why do we require a blockchain and what are the uses of blockchains. And then we'll transition into what are the popular blockchains that we use, what are the different blockchains we have, and then we'll transition into what are smart contracts, why do we require smart contracts, and we'll then transition later into Solidity and Remix. So Solidity is the language in which smart contracts are written, and Remix is the IDE where we compile, we run, and we test our smart contracts. So let's start with what is a blockchain. So if a layman asks me what is a blockchain, my simple definition would be a blockchain is basically an online book that stores data with the highest security. That's basically it. And if you want a more technical definition, it would go like this. It's a decentralized, trusted, distributed, immutable public ledger which forms a peer-to-peer network based on consensus algorithms. So let me break that down for you. Let's start with decentralized. Now, decentralized means there is no central authority or central entity that controls the system. So, in the classical world, for example, we have banks, or let's say RBI, right? RBI controls, or rather has control over every single transaction that occurs in India. So, and that may cause problems because even if a single server that is at RBI goes down for some reason, that may cause a huge amount of delay in a large amount of transactions that could have occurred, right? So that's a huge problem, and blockchain can solve this because there is no central authority, as I said before. So it's a completely decentralized distributed network where even if a node for some reason goes down, it does not affect the entire network, and the network can keep going. So the second word is trusted. Now this is very important. Now trust in a blockchain is built into the system, and so trust in blockchain is built into the system, and the different nodes in the blockchain need not trust each other, but the trust is built into the entire network where uh, through an through a system called so it's built into the system through public and private keys, and I'll be explaining what are public and private keys later in the webinar. So the next thing is distributed. So it's obviously a distributed system where every single person that is participating in the blockchain will have the copy of the ledger, and will be able to access the ledger at any single point in time. And it's immutable. Obviously, it's immutable because you can't change the details of transactions. You can't change the amount of transactions, and yeah, it's secure, and it's a public ledger as well. So anyone can access the ledger at any time, and it forms a peer-to-peer network. Now, this is also very important. Let's go back to our example where, let's say, I want to transfer money to some other account. Let's say I want to transfer 10 rupees to let's say Rahul's account, right? So how would I do that? I'll take my 10 rupee note, I'll go to a bank, and I'll deposit the amount, and the bank will take the amount. And the bank will update their ledger, and then they'll transfer the amount. They'll transfer the 10 rupees to a different account, and that might not be a same bank. Rahul's account might not be in the same bank, so they'll transfer it to a different bank, and then the second bank updates their ledger, and then the amount is transferred into Rahul's account, and then Rahul can withdraw the amount. So this is a very big process, and it's a time taking process, right? So what blockchain does is it eliminates the entire concept of banks, and it's a peer-to-peer network. So I can directly transact with Rahul, and I can just send him whatever amount I want in within seconds. So this reduces time, it reduces the commission that the banks take, which is very important. And and again, it's based on consensus algorithms. Now this is very important. Consensus algorithms are special type of algorithms which run on blockchain, that uh, that basically build in trust into the system itself. So for example, we have the Byzantine algorithm, the most famous one, and we have the proof of work algorithm, the proof of stake algorithms, and I highly recommend you to check them out on Google. They're very interesting. So moving on, now let's talk about the popular blockchains. Now, obviously, the most popular blockchain we have is Bitcoin blockchain, and it was built as an online cryptocurrency to facilitate transfer and assets and maintain the list of transactions. And it aimed to remove the intermediaries such as banks, as I told before. And the second most popular blockchain is Ethereum blockchain. And Ethereum adds another layer to the cryptocurrency transactions, which the Bitcoin did. And with the help of smart contracts, it adds another layer of development and with development tools to the blockchain, basically. So it is aimed at improving the development tools for blockchain, and this is done using smart contracts. So now let's see what are smart contracts. This A smart contract is basically a self-executing piece of code that runs on top of the blockchain, and it contains the agreement between two network nodes. So basically, all the transaction details and all the transaction agreements between two nodes will be run on top of on a smart contract, and the smart contract is a permit that which is which permits trusted transactions and agreements to be carried out among two distinct anonymous parties. Now, again, anonymous is important. You don't have to reveal your identity on the blockchain, and it's all done through your public keys and the participating blockchain network. And the implementation of these smart contracts opened up a whole new domain of building and development of decentralized applications, which are also called dApps. And all of these smart contracts run on top of EVM, which stands for Ethereum Virtual Machine. Now let's look at what are Solidity and Remix. So Solidity is an object-oriented programming language built primarily to develop smart contracts which run on various blockchains, but the most famous one being Ethereum, of course. And the smart contract compiled by Solidity run on Ethereum Virtual Machine, as I told you before, EVM. And all of these are written, compiled, deployed, and tested on Remix IDE, which we'll be looking into later, and we'll be building smart contracts. So let's actually hop back on to remix.ethereum.org, and we'll build smart contracts. So if you want to do a code along with me right now, go to Google and just Google remix.ethereum.org, and we'll be building smart contracts. So give me 1 minute. All right, I hope you can see my Ethereum dot remix.ethereum.org screen. And let's first familiarize ourselves with all of this environment here. And let's start off with the file section. So this is where you have all your files, and this is where you'll be writing your where you'll be coding your smart contracts. And here you have the compiler, Solidity compiler. So there are different. So Solidity provides you with the different versions of compilers um, that you can choose, and the most stable and the latest one being the 0.8.4. And language is Solidity, obviously. And we have the Ethereum virtual machine, the default compiler. And this is where you deploy and run your transactions, and you can test your smart contracts here. So Remix provides you with different public accounts. So all of these you see here are accounts which contain 100 ethers as a default value. And I can show you the address. So this is the address of the first account that we have. It's a hexadecimal code, and which is encrypted using SHA-256 algorithm. And yeah, you have 10 different accounts to play around and transact with, and it's basically a tool for developers to test their smart contracts. And next we have gas limit. So gas limit is basically an incentive for a miner to to basically take your transaction details and put them onto the blockchain. So let's go back to the example where I want to pay Rahul 10 rupees, right? So how would I do that on a blockchain? So first, I'll take my private and public key. I'll encrypt the amount details and the transaction details, and I'll hit send on the blockchain. So this list of transaction details will be stored in a pool of transactions where the miners can choose which pool of transaction they want to select and put on top of a blockchain. So the higher the gas limit you set, the faster your transaction will be proceeded. So it's basically an incentive for a miner to take your transactions and put them onto the blockchain. And gas limit later will be converted into Ethereum and then provided to the miners for their work of putting your details onto the blockchain. And we have ethers here which we can transact. We can This is basically for us developers to transact and test out our smart contracts. And so we'll start with the first program. We'll first create a new file. Let's say, let's call it transact.sol. So for all the Solidity programs, the extension is .sol. And we'll start with the first contract here. So I'll explain you this first sentence. So Pragma Solidity and 0.8.4. So why did I use Pragma Solidity? So basically, whenever you start writing code in Remix, you need to specify which compiler version you're going to use. So this is done using the keyword Pragma Solidity. All right, so we'll start the contract with the keyword contract, and we'll give it a name. Let's say transact again. And contracts in Solidity are basically like a class in Java, or let's say in C++. So you can relate a class to a contract in Solidity. And we have data types in Solidity as well. The first one being uint. Uint is basically an integer, but an unsigned integer, which is also available in Java and C++, and it's the same data type. So it holds all the values from 0 to 2 power 256. So we'll initiate. a variable, let's say amount, and so in this first contract, I'll explain you how to transfer Ethereum from a smart contract to a Ethereum address, to a random Ethereum address, and vice versa. So to transfer amount, we'll write a function. Let's call it pay, and we'll keep the function public. Public is basically a moderator, which is the same as in Java or C++ again. And I'll write another keyword, payable. Now, what does payable do? So payable basically tells Solidity compiler that this function that we are going to define can receive Ethereum from an address. So there are functions without payable which won't be able to receive Ethereum, or which won't be able to receive cryptocurrencies. So payable tells the compiler that we are going to receive Ethereum in this function. So we'll just say amount is equal to msg.value. Now again, msg.value is it's a predefined variable where it always holds the value that is sent to to a smart contract. So whenever we say payable, we know that we are going to receive Ethereum to the smart contract, right? So whenever you use payable, you can use msg.value, which is a standard variable which holds the value that is sent to the smart contract, and that'll be our first function. Now, now we have sent Ethereum to our smart contract, but we need to check how much we have sent, right? So to return the amount that we have received, we'll create another function that'll go like um, function, let's say get amount. This will be again public. View again. Now I'm using the keyword view. It's again a predefined keyword in Solidity, which basically states that this function will not change the value of any state variables. So here we have one variable, that is amount, and we're not going to change any value in this function, right? So we use view as the keyword, which does not allow us to change the state of any variable inside this function, and the function will returns as an integer. All right, so we just return the amount which we see, and yeah, now we can compile. All right, we have a warning here. Let's just remove the warning. So in Solidity, I think yeah, the Solidity 0.5.0, from 0.5.0 they introduced a licensing statement. So we need to license every single time we build a smart contract. So let's give. All right, so let's compile again. Right. So here we can deploy, and we'll select the first account to deploy our smart contract. And this is where you can see pay and get amount are two functions that we have. So now let's pay some ethers. Let's pay 3 ethers. Let's say pay and get amount. There you go. We have 3 ethers. The default values that Ethereum that Remix uses is in way. So that is this. So one way is equal to 10 power minus 18 ethers, which is a pretty less value, and that is the default value that Remix uses. So we have 3 ethers. Let's pay 5 ethers now and get amount. There you go. We have 5 ethers in our smart contract. So now you might ask me, I paid 3 ethers first, and now I paid 5 ethers again. So the total should be 8 ethers, right? That's right. But we are only checking the value of the amount. We are only returning the value of amount. Now amount is equal to msg.value. Now what does msg.value do? It just takes in the value that was returned, that was given to the smart contract at a point of time. But the value we require is 8 ethers, right? Which is in the smart contract. So for that, we need to create another function. Let's say get balance, and it'll be an again public function, and view returns an integer. So here we just return address of this. All right, so we're returning the address of this smart contract. This keyword is an again predefined keyword in Solidity, which refers to the smart contract, and we're returning the address of this smart contract, and we are using the function balance, which is again a predefined function in Solidity, which returns us the balance that the smart contract contains. So we'll compile again, and we'll delete the previous instance and deploy. Now here we go. We have the third function get balance here. So let's do the same payments. Let's pay 3 ethers first. Uh, let's first check the amount initially. It's 0, and the balance is 0 as well, right? So now let's pay 3 ethers. Let's check the amount. There you go. We have 3 ethers. Get balance 3 ethers again. So now let's pay for 5 ethers again. Let's say pay, and if you check the amount, it'll show you 5 ethers. But if you check the balance of the smart contract, there you go. We have 8 ethers in our smart contract. So that is how you transfer Ethereum from Ethereum address to the smart contract. So here you can see we had 100 ethers at the start, and we have 84 ethers right now because we paid those many ethers to the smart contract. Now let's see how you can pay a Ethereum address from a smart contract. So from this smart contract, we'll pay an Ethereum address. Right. For that, we need another function. It's a function. Let's call it receive, and this function will take an argument, which is the Ethereum address that we are going to pay. So let's say address payable. Again, the payable keyword is the same as we used before. So here we use payable keyword for the entire function, which says that the function is capable of receiving ethers. But here in this case, we are referring payable keyword to address which will be receiving our ethers. So Let's call uh, the address as account maybe one. Yeah, and this will be a public function again. And inside the function, we just transfer the amount. Account one dot transfer. Let's say 3 ethers. Right. So now let's delete the previous instance and let's compile the contract, and let's deploy with the second account. Deploy. And here we go. We have the third function as well. So in order to transfer Ethereum from a smart contract to another address, we first need to have the enough ethers in our smart contract to transfer. So let's check the balance. We have zero in our smart contract. So if we try to pay, let's okay. First of all, let's provide an argument here. Let's pay the last account. Let's copy the address and let's pay from this account. Let's say we want to pay 5 ethers again. I hit pay, and we have the list of transactions that we are recording here. So we've paid and balance 5 5 ethers here. Now let's try to receive 3 ethers from the smart contract to the last address here. Let's just say receive, and there you go. We have a tick mark, and you can also check all the transaction details down here. I'll just maximize this. Yeah, we have the status. We have transaction mined and executed successfully, and we have the transaction hash. We have from address. We have the to address, and we have the gas, and you have hash, and you have the input and deep output which have been encoded. You can check all of those. This entire detail, transaction detail, will be written on top of the blockchain, right? So let's check. Yeah, here you go. I paid 3 ethers, and there is 102.999 ethers, and those remaining ethers were given to the miner, which was basically uh, 30,000 gas limit. So that was converted into ether, and that was paid to a miner who took the transaction details, all of these transaction details, and put it on top of a blockchain. And the remaining ethers were given to whoever I wanted to send. Right. So we've completed our first contract, and we'll do another contract where I want to showcase how flexible or how diverse the blockchain technology can be. And blockchain is not just related to cryptocurrency. So I'll explain you how it can be used in different forms. So in this smart contract, in the second smart contract, we'll actually book a hotel in we'll book a room in a hotel, and I'll show you how to do that with blockchains. So let's create a new file. Let's name it hotel room, and we'll give the license. And we'll give the solidity compiler. This time we'll use an older version of the compiler because it has less errors. So let's use 0.6.4, and so we'll start the contract. This time let's call it book a room, or let's just call it hotel. And all right, so first of all, we need what do we need to book a hotel? We need to pay the owner, right? So for that, we'll first um, we'll first take an address which we'll be paying. So uh, again, address is a keyword in Solidity which holds hexadecimal values, which are basically Ethereum addresses that run on top of the blockchain. And so let's use address payable. Again, we need to be able to pay the address, right? So address payable, and let's call it owner. Will be a public owner, so that every member in a blockchain can pay the amount and book a hotel. And we'll use a constructor to initialize our variable. Constructor will be a public constructor, and we'll initialize the owner to msg dot sender. Now again, msg dot sender, similar to msg dot value, is a predefined method in Solidity that basically holds the value of whoever calls the smart contract, right? So whenever I deploy the smart contract here, that deployment address will be stored in owner, and that will be also stored in msg dot sender basically. And yeah, we'll write our functions now. Function, let's call it book a hotel, book a room, or let's just call it book. And it'll be a payable function, obviously, and it'll be public. All right, so here now in order to book a hotel room, you need to first pay the owner, right? So let's say owner dot send. Let's send the value that we received. Now again, msc dot value is the same keyword that we used before, which will store the amount that is sent to the smart contract. And before we send the amount, we need to make sure that the sender has the required number of ethers within his account, right? So for that, we use another function called require. And let's say the hotel room costs us, let's say 3 ethers. So we write msd.value. Value should be greater than or equal to 3 ethers, right? So what what this function does is require basically does is whenever we have the value greater than, sorry, 3 ethers here. Yeah, so whenever the msg dot value is greater than equal to 3 ethers, it will proceed further into the function. But whenever this condition fails, it will execute whatever we have after the comma. So here we can just type an error message where, let's say, not enough ethers provided. Right. So what require does is, again, if the value of msg dot value is greater than or equal to 3 ethers, it will uh, it will proceed further into the function. But if the condition fails, it will just execute what we have on after the comma. So here we have an error message saying not enough ethers provided. And and also one more thing, for before we book a hotel, we need to make sure that the hotel room is empty and it's not preoccupied by a different owner, right? So for that um, we need to create another structure called enum. Now enum is the same structure that we have in C++ or Java, and it works the similar way. So enum, let's call it status of the room, status. And a room can have two status, right? It can be either vacant or occupied. So let's use that. Say the vacant or occupied. And we'll initialize a variable for the structure, which will be, let's call it current status of the room. And yeah, so after we've initialized, we need to initialize the variable current status in our constructor. So before we book a hotel, it's always vacant. So we will initialize current status equal to vacant, status dot vacant. So we have our room vacant initially, and after we provide 3 ethers and after we send the amount to the owner, we changed our current status to status dot occupied. So current status dot occupied. There you go. And so we've done our contract, and let's just go over it again. We have our contract starting from here. We have the address owner and we have the enum to represent the status of our room. And then we have a variable representing the status. We've initialized the variable, and we have the require statement as well. And we need before booking a function, we need to make sure that the room is vacant, right? So again, require. This time we require the current status to be equal to status dot vacant. So we need it to be vacant before we book. And if this condition fails, we'll print an error message saying the room is already occupied. Yeah, and we're done. So let's try and compile. Again, we have a warning. We can ignore this warning. This warning is because we are using older version of Solidity, which is 0.6.4, and we can ignore the warning for now. And let's take this address, which contains 100 ethers now, and we'll try to uh, pay the smart contract and book a room. So let's first deploy. and we have the book function here. Let's just book it with uh, 0 ethers first. That is not enough ethers. If I hit book, it'll show me an error. There you go. PM error, and it was reverted. Why? The reason provided by the smart contract is not enough ethers provided. Again, we provided 0 ethers, whereas the room costs us 3 ethers to begin with, right? So now let's pay 3 ethers. Now book. There you go. We have a blue tick, and we have the transaction details here. We have the value 3 ethers, and we have the status through transaction mined and executed successfully, and we have all the transaction hash from address to address and gas limit and all of the details. And now that we have booked, let's let's try booking it again, so that we meet this condition where this condition will become false, and we need to get the error, the room is already occupied. So we've already booked the room, and we'll provide 3 ethers again, and let's try to book it again. There you go, we have an error again, and the reason provided by the contract is the room is already occupied. And this is how we can use blockchains and solidity and smart contracts uh, to basically solve any problem, uh, like booking a hotel room. So instead of you going to the reception and then talking to the receptionist and then booking a hotel, you can just book it in your laptop or in your mobile device, and without any human interaction, you can directly book hotel rooms. And yeah, this is how smart blockchains can be used in different ways. And again, I'm reinstating again, blockchain is not just Bitcoin or not just cryptocurrency, and it can be used in many other ways. So this will be the end of our webinar, and um, and we have the attendance link in the chat box, and I want all of you to fill the attendance form. So yeah, thank you for joining in. And if you want to connect with me, we have all the links in the description. And if you want to keep up with ISTE as well, we have all the links in our description. And yeah, you can always connect, and I'm ready to talk anytime about blockchains or about the technology or about tech in general. So yeah, thank you for joining in, and stay home and stay safe.